Hi, I'm Alexander Ryazanov. I'm the Chief Technical Officer of IPSNIP Computing. In this short video, I'm going to demonstrate how our query tool Hydra can be used to formulate a query that may serve as a diagnostic variable, for example, for sepsis monitoring. In this demo, the diagnostic variable will be a test for pre-existing diabetes diagnosis. This may be useful, for example, if a patient has high blood sugar level and we want to ensure that it's not simply because the patient has diabetes. Then we can use the blood sugar as a diagnostic variable for sepsis. So I'm starting to compose a new query that will find patients in our model database who had new or confirmed diagnosis of diabetes within the last year. I'm entering the title for the new query, current diabetes diagnosis. What we have here is a fresh query canvas. Now I'm entering the first key phrase. It's just patient. You can see that the system has created a query node patient. I'm happy with it, so I pin it. Patients are identified primarily with their medical record numbers. So I enter medical record number as another key phrase. As you can see, the system has suggested a reasonable graph, but let's see if it can be improved. Yes, this graph is a bit better because it explicitly mentions the medical record number class. Now I'm adding some auxiliary relation essentially to identify the specific data value for the medical record number. Represents value. And this will be the variable name for the corresponding values, patient ID. I'm happy with the query graph so far, so I'll click on Pin All. Now I want to say that the patient has a diabetes diagnosis. So here is the key phrase, diabetes. And this system suggests a completely reasonable graph for it. Patient has diabetes. Now I want to restrict the time of the diagnosis, so I enter time as the key phrase. Okay, in this graph, the relation Azov specifies the diagnosis time, and we also say that it's before some other time, which will be actually our current time. So this node time will be our current time. Let's call this node, let's say, diagnosis time. We actually want to see the diagnosis time in some readable form in query results, so we request to print it. Here is the predicate print. And the variable for readable time will be, say, diagnosis time string. Now we want to specify the current time. Again, we are using the auxiliary predicate represents value, sorry. I'm assuming that the current time is the 1st of October, 6 o'clock. And it's given in XSD date time format. Now a bit more tricky thing. We have to say that the diagnosis is at most 1 year old. So I'm adding a special filter. Here is the filter expression I prepared previously. It says the distance between diagnosis time and time is at most 1 year. Let's check the filter. It's okay, so I'm just adding it. Before I test the query, I want to show briefly the study services available for query execution. So I go to the registry. This is just a list of services on our model clinical database. They constitute our virtual database that we can query. So for example, here is the service that is likely to be the main service for our query. It simply extracts diabetes diagnosis for a given patient, possibly with from several data sources. Let's now run the query in this Execute tab. So you can see that Hydra has found 2 patients in our model database. And it also provides readable diagnosis time here. And finally, we can save the results for convenience in an Excel spreadsheet. So here's the generated spreadsheet. This concludes my demo. Thank you. You can find more demos like this on IPSNIP's website.